Maya opened order 1847. Green, confirmed. Payment captured. Shipping count, 0. She searched the delivery line. No message. Noah called. The customer was charged. The warehouse sees nothing. Pickup leaves in 40 minutes. Maya searched for an error. None. Nothing was waiting to retry. So the order worked, she said, and it is gone. Maya called Lena in shipping. Can your service still receive new orders? Lena opened the shipping feed. Newer orders were arriving. Labels were printing. The warehouse workers had no growing error list. We are alive, Lena said. We never received 1847. That changed the question. Shipping had not rejected the order. Shipping had never heard about it. Between the two services ran a delivery line. A confirmed order drops a small message into it. Shipping picks the message up and starts work. Maya opened that line. Maybe the line was simply late. Maya checked the waiting count. 0. She searched the completed messages. Order 1847 was not there either. The line was healthy. The message had never entered it. Noah shared the customer's confirmation screen. The order existed. The payment reference existed. After the restart, the page showed confirmed. Maya opened the order service timeline. One line said, order saved. The next expected line was missing. Then she saw a restart marker. The service had stopped after the save and before the send. She opened the code. It looked harmless. Save the order. Then tell shipping. 2 lines. 2 systems. 2 separate promises. The database said yes, Maya said. Shipping was never even asked. The service had restarted clean. It kept no memory of a job half done. That was why there was no error to find. Maya reached for the fastest patch. Send the message first, save the order second. Lena stopped her. What if the save fails after I receive it? Then shipping could create a parcel for an order that did not exist. The gap would still exist. It would only face the other direction. Maya tried a second idea. Then retry every send after a restart. That sounded safer. It created another problem. A send can succeed while its reply is lost. After a restart, the service cannot know that shipping already heard it. The retry can deliver the same order twice. They did not need a faster guess. They needed one promise that could not be lost. Their database save could not include the delivery line. So Maya stopped trying to make 2 systems behave like one. So she put the message where the order already was. One small table sitting beside the orders. Now a single save wrote 2 rows. The first row said the order was confirmed. The second said shipping still had to be told. Both survived together, or neither existed. The save cannot leave one behind now, Maya said. A small worker watched the table. It delivered each waiting message, then marked the row as sent. If the worker stopped, the message remained stored. This is the Transactional Outbox Pattern. The name is not the useful part. The useful part is where the promise now lives. Maya drew the new path. Lena found one more gap. What if the worker sends the message, then stops before marking it sent? Maya looked at the diagram. The row would still appear unfinished. After restart, the worker would send it again. The outbox closed the old save before send gap. The message stayed stored until a worker sent it, but it did not promise exactly one delivery. So, Lena added one garden shipping. Every message carried a stable ID. Shipping saved that ID and the new shipment together. If the same ID arrived again, shipping ignored the repeat. These numbers come from a small program written for this reconstruction. Not a real store, not a measure of speed. It checks these steps only. Old path. 1 order saved, 0 messages sent. Outbox path. 1 order and 1 waiting message, saved together. Then the worker delivered that same message twice. Shipping created one shipment. The new code would protect future orders. It could not invent the message already lost. Maya still had to repair 1847. She checked 3 facts. The order was confirmed, payment was captured, shipping had no parcel for it. Then she created one recovery message with a stable ID tied to that order. Lina watched it arrive. Shipping saved the ID and shipment together. One label appeared, one parcel entered the pickup queue. Noah refreshed the support case. The warehouse has it. Pickup had not left. Before they closed the incident, the team made silence loud. Lina set an alarm on the oldest message still waiting. A stuck worker could no longer hide behind the healthy order screen. Every receiving service now remembered the IDs it had seen. A repeat could not repeat the work. Then Maya wrote the test she wished had existed. It forced a stop after the save. Then it forced one after the send, before the row was marked done. Every time, the ending had to be the same. One confirmed order, one recorded message ID, one shipment. The message could arrive twice. The second arrival could not create more work. The test did not stop failure. It stopped failure from erasing the promise or repeating the shipment. Order 1847 was never missing from the database. It was missing from the next person's world. That is the danger of saving here and sending there. Do not trust the quiet space between 2 successful systems. So keep the promise next to the thing you saved. Deliver it in the background. Expect that it may arrive twice. Make the other side remember. The order was saved. This time, shipping heard.